Hi everyone. In lesson 6.4, we're going to learn about how to solve equations that involve inverse functions. So just like in 6.1, we're starting out with inverse functions in our equations, and we're solving for side ratios instead of solving for angles. These are just a little bit more complex, a little bit different than what we did from 6.1. So before we do that, I want us to practice how we would find an inverse if we're solving an equation. So we want to solve this equation for x. Like, how do we work backwards? So first we need to get rid of the 3, so we divide by the 3. So you have y over 3 is equal to cosine 2x. So since that cosine of 2x the 2 is inside the cosine, we can't divide by 2, we have to get rid of the cosine first. So we would take the cosine inverse of both sides to cancel that. Then we'd have the cosine inverse of y over 3 equals 2x. And then to get rid of the 2, we would divide by 2. So finally, we got that x equals 1/2 cosine inverse of y over 3. Okay, so that was just practice solving a literal equation that has more than one variable. Our equations that we're actually going to solve don't have more than one variable, but we use some of the same skills that we just did here. Okay, so let's take a look at our first example. Oh, I gave you some hints of what to do, so I would pause and write that down real quick. So when we are using these, they have the inverse to begin with, so that means we're solving for angles. Like I said, I wrote angles, I meant sides. Solving for sides. So we would also be in restricted quadrants. Okay, so our first example says 2 arcsine of x equals pi, so we need to get the x by itself. So we would divide by 2. So we can write it as arcsine, or you can write it as sine -1. I like doing the sine -1, it just seems faster. And then what would we do to get x by itself? Good, we would take the sine of both sides, because that's what's going to cancel out the sine inverse. So then I'd have x equals the sine of pi over 2. And so from there, we would just have to find out what the sine of pi over 2 is. And we know pi over 2 is right here, and at that point, sine is equal to 1. Okay, so that's pretty much it. Let's try the next, well, why don't you pause and try this one. Okay, so I hope you got root 3. So we first would divide by 3, take the tangent of both sides, so we'd have tangent of pi over 3. And then we look at that triangle, pi over 3 is equal to 60, so the tangent would just be root 3. Okay, good. So let's look at the bottom. These ones are a little more complex. It's kind of like the ones that we did in 6.1, where you had like 2 things and you had to draw the triangle for the inside and then take the cosine of the outside. So if we took the cosine of both sides to get the x by itself, we would have that x equals the cosine of the sine inverse of 1/2. So like I just said, we're going to draw the picture for this part and then take the cosine of that answer. Okay, so we're going to draw a triangle. So we're in restricted quadrants, so sine's only positive in quadrant 1. So sine is 1, 2, this is our root 3. So our reference angle is 30. Not that that really matters here, because we're trying to find the cosine of this picture. So x would equal the cosine of 30, because this is 30 degrees. So x equals root 3 over 2. And that's it. Okay, so let's try the last one and then we'll be done. Okay, so for this one, we'll take the secant of both sides, just like we did on the last one. So we get that x equals the secant of the cosecant inverse of 2. So we'll draw a triangle for this part. So cosecant is like sine, so it's positive in quadrant 1. So if we have the cosecant inverse of 2, that would be the sine inverse of 1/2. So we have the same picture we had before. So now we want the secant of that though. So we would have to flip it over. So cosine would be root 3 over 2. So that means that secant would be 2 over root 3, which would equal 2 root 3 over 3. And that's it. So when you have the two functions in one, like the ones we just did, you draw a picture for the inside and then find whatever they're asking for of the picture. And that's it. I hope you like these 6-minute notes. Werner out.